Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. See the next topic, reaction enthalpy or heat of reaction. The amount of heat absorbed or released during the complete course of reaction as represented by balanced chemical equation is called reaction enthalpy. When reactants are converted into products, then some cases heat energy is absorbed, some other cases heat energy is released. That heat energy is called reaction enthalpy or heat of reaction. Example, C plus O2 gives rise to CO2. Delta H equal to minus 94.3 kilocalories. That means during the formation of carbon dioxide from carbon and oxygen, 94.3 kilocalories of energy is released because here negative sign is represented. So see here this one, negative sign means this much amount of heat energy is released. 12 grams, here carbon 1 mole means 12 grams of carbon reacts with 32 grams of oxygen to give 1 mole of CO2, that is 44 grams of CO2 along with 94.3 kilocalories heat evolution. So general formula, enthalpy of the reaction delta R H equal to sigma I into AI into enthalpy of the products minus sigma I BI into enthalpy of the reactants. Okay, see the related numerical. Enthalpies of formation of CO, CO2, N2O and N2O4 are minus 110, minus 393, 81 and 9.7 kilojoule per mole respectively. Find the value of delta RH for the reaction. Here delta RH means enthalpy of the reaction. N2O4 plus 3CO gives rise to N2O plus 3CO2. For this reaction, enthalpy of the reaction we should calculate. So formula, enthalpy of the reaction or reaction enthalpy delta RH equal to sigma of enthalpy of formation of products minus sigma enthalpy of formation of reactants. Here delta FH means enthalpy of formation. So here enthalpies of formation of products and reactants are given. Here what are the products? N2O, CO2. So enthalpy of the N2O plus how many moles of CO2? 3 moles. 3 into enthalpy of the carbon dioxide. Here enthalpy of the N2O plus 3 into enthalpy of the CO2 minus enthalpy of the reactants. This one reactant and 3 into enthalpy of the CO. Substitute the values and do after calculation we can get enthalpy of the reaction 777.7 kilojoule per mole amount of heat energy is released. That's why represented with negative sign. So this numerical is related to enthalpy of reaction. Okay, next say this, standard enthalpy of reaction delta R H naught. The enthalpy change for a reaction when all the participating substances are in their standard states is called standard enthalpy of reaction. All the participating substances means both reactants and products are present in their standard state, then enthalpy change of that reaction is called standard enthalpy of reaction. Now, what is standard state of a substance? How can we define? Means the standard state of a substance at a specified temperature is its pure form at 1 bar pressure. At 1 bar pressure, at a specified temperature, the pure form of a particular substance is standard state of that substance. Example, standard state of liquid ethanol means liquid ethyl alcohol at 298 Kelvin is pure liquid ethanol at 1 bar pressure. So at 1 bar pressure at 298 Kelvin temperature, liquid ethanol present in pure liquid form, that is standard state of that substance. solid iron at 500 Kelvin temperature and 1 bar pressure present in the form of pure solid. So that is the standard state of solid iron. See this, most of the cases temperature considered as 298 Kelvin. Only some cases we can consider other temperature like in this example. Okay, next. Reaction enthalpy is of different types, depends upon type of reaction. What type of reaction? Means combustion reaction like this, enthalpy of combustion reaction, neutralization reaction like this. Depends on the type of the reaction, we can define different types of reaction enthalpies. First one, enthalpy of combustion. The amount of heat evolved when 1 mole of substance is completely oxidized in air. That means in presence of oxygen. Oxidation takes place is called enthalpy of combustion. It is always negative because it is exothermic in nature. See this, any compound treated with oxygen and oxidized completely means some amount of heat energy is released. Because of that, this enthalpy of combustion value always negative. See the important points. C plus O2 gives rise to CO2. Delta H equal to minus 94.3 kilocalories. When carbon is oxidized by oxygen to CO2, this much amount of heat energy is released. See this, C plus half O2 gives rise to CO. Here equation 2 does not represent enthalpy of combustion because in this carbon is not completely oxidized. This is partial oxidation. Already we know that carbon undergoes partial oxidation, we can get carbon monoxide, and complete oxidation we can get carbon dioxide. So this heat energy is called enthalpy of combustion. In this, heat energy is not considered. In equation 2, heat energy is not considered, enthalpy of combustion of carbon. Okay, next. 2H2 plus O2 gives rise to 2H2O. Enthalpy change is enthalpy of the reaction or enthalpy of the combustion delta H equal to minus 115 kilocalorie. Here enthalpy of combustion of H2 is minus 115 divided by 2, that equal to minus 57.5 kilocalorie. Because since 1 mole H2 be taken, here in the equation observe carefully 2 moles of hydrogen, but enthalpy of combustion means 1 mole of the substance undergo combustion or oxidized completely. Here 2 moles means we have to consider for 1 mole. So this energy will be reduced to half of the value, that is this. So for the enthalpy of combustion of 1 mole of H2 value is 57.5 kilocalorie. Okay, see important thing, 3 Mg plus N2 gives rise to Mg3N2, magnesium nitride. In above equation, delta H is not heat of combustion because oxidation is not by oxygen. Here magnesium oxidation state changed from 0 to positive oxidation state, but this is not combustion reaction because this oxidation is not done by oxygen, oxidation done by nitrogen. That's why this type of reaction, the heat energy involved in this type of reaction is not heat of combustion. So heat energy released when a particular substance, 1 mole of the particular substance undergoes complete oxidation with oxygen, that only enthalpy of combustion. Okay, see the numericals. According to the equation, C6H6 plus 7 by 2 O2 gives rise to 6 CO2 plus 3 H2O. Delta H equal to minus 3264 kilojoules. The energy evolved when 3.9 grams of benzene is burnt in air will be. Okay, equation is given, enthalpy of combustion value also given. 3.9 grams of benzene undergoes combustion means then released heat energy how much? This is also benzene formula. According to this molecular weight of benzene, according to this equation, 78 grams of benzene, enthalpy of combustion value 3264 kilojoule. In question, 3.9 grams of benzene undergoes combustion means how much amount of energy, heat energy is released. So do the cross multiplication, we can get this one. 163.2 kilojoules of energy is released for 3.9 grams of benzene undergoes combustion. So what is the option? Option D is the answer. Okay students, we'll meet you in the next class.